Welcome to the Explainer. Have you ever stopped and really thought about how that box of metal and silicon on your desk actually understands what you tell it to do? It's a fascinating question, and today we're going to get into it.
Okay, let's dive right in. When you or anyone writes code, the computer doesn't actually get what Python or English or any of those languages mean. It's just a machine, right? It's basically a bunch of tiny switches. So how on earth does it turn our commands into actions?
Well, the first clue to solving this mystery is understanding that computers have their own native tongue. It's a secret language that looks absolutely nothing like the code we're used to seeing, and it's the foundation for everything a computer does. This language is called binary, and it is incredibly, almost ridiculously simple. It only has two symbols, 0 and 1. That's it. The entire digital universe, everything, is built on just those two characters. But here's the really cool part. These aren't just random numbers. They represent actual physical states inside the computer. A 1 means a tiny electrical signal is on, and a 0 means it's off. It's literally a language of physics.
And this is the bedrock of all computing. Everything, and I mean everything, from the app you're using right now to your movies to the code a programmer writes, it all has to get broken down into millions and millions of these little on and off signals.
Which, brings us to the next big question. If our code starts out as text that we can read, how does it make that leap? How does it get transformed into all those zeros and ones that the machine actually needs?
The answer is pretty clever, actually. It's a special kind of program that acts like an expert translator. Its whole job is to be the bridge between the way we humans think and the way a computer really, truly operates.
Now, there are two main types of these translators. On one side, you have what's called a compiler. Think of it like translating an entire book into another language before anyone starts reading it. It just does the whole program at once. On the other side, you've got an interpreter, which is more like having a live translator by your side, translating your code one line at a time as it runs.
So the whole journey for your code follows this really clear path. It starts out as a high-level language, something like Python that's pretty easy for us humans to read and write. Then the translator gets to work, converting it to a low-level language like assembly, which is way closer to the machine's level. And then finally, that assembly code gets turned into pure machine code, the raw binary instructions.
Okay, so once the code is in its final binary form, it's ready. It gets sent to its one and only destination, the brain of the computer.
And that's the CPU, the central processing unit. This is the part that does the real work. It's the core component that actually reads all those strings of zeros and ones and performs the calculations and actions that your code wanted to happen in the first place.
And the instructions the CPU understands are incredibly basic. Seriously, every complex thing you want to do, like show this picture or play this music, gets broken down into the simplest possible tasks. We're talking things like add these two numbers or move this piece of data over here.
What makes this whole system work? What makes it even possible? Is the unbelievable speed. This entire process, from human-friendly text to physical action, it all happens in microseconds. That's exactly why when you click Run on a program, the result feels completely instantaneous. It's magic, but it's physics.
This whole process also helps explain why there are so many different programming languages out there. It really all comes down to trade-offs. You have compiled languages like C++, which are usually faster because all that translation work is done ahead of time. But then you have interpreted languages, like Python, which might be a bit slower, but are often way, way easier for a human to write and understand.
But here's the key takeaway. No matter the language, no matter if it's compiled or interpreted, it doesn't matter. In the end, all roads lead to one single destination, a precise set of binary instructions that the CPU can execute. So, the next time you see a line of code, or even just click on an app icon, take a second to remember what's really happening under the hood. You're not just typing commands. You're literally speaking to a silicon brain in its own secret language. And that is a truly remarkable kind of communication.
Okay, so we've just decoded how computers understand structured, logical code. But what about us? What about the messy, nuanced, and sometimes emotional way that we humans talk? How does an AI make any sense of our language? Well, we're going to explore that very mystery in our next explainer.